In this trig survival guide, we're going to verify a trig identity. So we'll be looking at this identity, and we will use several strategies, but we are going to highlight the strategy where we simplify or combine like terms. So let's go ahead and get started. Remember that before you take any steps for verification, you should do a little bit of analysis and strategizing at the beginning. So we know that we can only manipulate one side, so we should choose which side we want to start with. Usually that's going to be the more complex side. So in this case, it looks like the left side will give us a lot to work with. Another thing to notice is that we'll use multiple strategies in order to get the left side to look exactly like the right side. So we're basically going to manipulate it until we get to cosine theta. And a final thing is that there are multiple correct solutions, and yours may look a little bit different from someone else's, but as long as you've made correct substitutions, your solution will be a correct one. So let's start on the left side, and I like to draw my vertical line here so I'm not tempted to work on the right side. So you can only do manipulations or substitutions that impact the left side. So let's start by changing everything into terms of sine and cosine. So we'll rewrite secant using its reciprocal identity, 1 over cosine theta. And then we have this next term, sine theta and tangent of negative theta. So I'd like to use an odd identity here. We can replace tangent of negative theta with negative tangent of positive theta. And that's just going to be a little bit easier. So we know that, again, those two terms are connected by multiplication. So a positive sine times a negative tangent. We're actually going to subtract here. And now we can rewrite sine theta as is. We'll put it over 1. And then tangent is going to be sine theta over cosine theta. And now all our terms are in terms of a positive theta. And this is going to need to equal to the right side. So I'm going to abbreviate RS for right side. That's just a little bit shorter than rewriting cosine theta every time. All right, so now we're ready for our next step. We pause and assess and see that both of these terms have a denominator of cosine. So these are actually like terms, they have like denominators. And so we can rewrite this as a single term. And we'll do a little bit of simplifying in this step as well. We'll have in the numerator 1 minus sine times sine is sine squared. And that's all going to be over cosine theta equal to our right side. Now reevaluating, we see we want to get this expression, now we have it as a single term, which is great. We want it to reduce to a single cosine. So we need to be looking for some identity or some substitution that will give us only cosine in this expression. So let's zero in here on the numerator, and we see that 1 minus sine squared should actually look like one of our Pythagorean identities. Remember, a Pythagorean identity, cosine squared plus sine squared equals 1. And if you rearrange that slightly, if you subtract sine squared from both sides, we know that cosine squared should be equal to 1 minus sine squared. And so we can replace our 1 minus sine squared with cosine squared. So let's do that as our next step. So we have cosine squared over cosine. And hopefully now you see we are basically there. So we have 2 cosines on the top, that's that cosine squared, a single cosine in the denominator. So we can cancel out that common factor of cosine. And in the numerator, we're left with a single cosine. That's just over 1. So we have proved this trig identity. Cosine theta equals cosine theta. I'll post a link in the video description with more worked examples. So be sure to check that out. Remember that verifying trig identities gets easier and easier with every single one that you complete. Good luck and thanks for watching.